All right, here we go. Suppose a function f has an inverse. If f of 0 equals -1 and f of -1 equals 2, find a, b, and c. And remember, an inverse undoes the previous function. It gets you back to where you started. Remember we said g of x, or g of f of x. So if we plug in x into the f function, and then we plug that output as the input into the g function, we get back to the input that we plugged into the f function, so back to x. And that's what's going to be going on here in these problems, that we need to figure out what was plugged in and how can we get back to that. So the inverse of f, and we're plugging in -1 into that inverse. Now, before, what output gave us -1? Well, 0 did. So then we've got to, by plugging it into the inverse, it's got to undo what happened in the f function and gets back to 0. So f of -1, or sorry, the inverse of f of -1 gives us 0. Because again, if we plugged in 0 to the original function, we got out -1. Now if we plug in -1 into the inverse, we've got to get back to what we plugged in to begin with, so 0. All right, f of -1 of, the f inverse of f of 0 gives us, well, if we're plugging in, or that's kind of our definition right there, we said of g of f of x equaled x. So then if we're plugging in f of 0 and then plugging that output into the inverse, this gets us right back to 0. And this really is the same thing we had right here in A. Just now we're being more specific about where this -1 came from, and that -1 is from f of 0. So we have f inverse of f of 0 equals 0. And lastly, again, kind of a piece of definition of the f inverse of -1. Over here, we don't see it defined specifically. We just know it's the inverse. So if I'm plugging in the inverse into that output into the function, we get, again, back out to our original input. So back to 2. If 2 is plugged into the inverse, and it is actually an inverse of a function, then plugging that back into the function gets us right back to where we were. Now, hope that helps.